So today we're doing 7, 8, which is square roots. Thank you. So we were looking at square roots before, so it's kind of a continuation of that. And irrational numbers. So square roots and irrational numbers. So we talked about rational numbers were any numbers that could be written as a fraction. So rational numbers then include like normal integers, like 5, because 5 over 1 is a fraction. It includes decimals that stop, or the fancy math word is terminate, decimals that terminate, that don't keep going for forever, or decimals that repeat. Now, irrational numbers are going to be numbers that don't fit those. And maybe I'll start with that right now. So irrational numbers. So irrational numbers. So that then we could say, all right, those. They're going to be decimals that don't stop or repeat. Or we could kind of go back to our definition of rational and say numbers that can't be written as a fraction. But essentially, they're going to be numbers that have decimals in them that don't terminate or don't stop, or they don't repeat. And if you had to get an example of one of those, you could say an example would be pi. Nice. So pi is a number that goes on for forever. There's people who their job is to actually figure out the next digit of pi. I know they're up over 1 million digits. How they do it, I don't know. But they haven't found any repeating anywhere in there. They haven't found an end to it. How this ties into square roots is some square roots are also going to be decimals like that. So I'm going to say comma after pi. And like square root of 2 is one that math teachers often use. You punch square root of 2 into your calculator. It's going to come up with a decimal that goes to the end of your screen. And it's not going to have any repeating in it at all. The thing I want to add to this after my irrational numbers is real numbers. And I'm just going to throw that down here at the bottom. Real numbers are going to be the numbers that include all rational numbers and all irrational numbers. So really you could write it's all numbers used so far. So when you get into like algebra 2, you'll learn about imaginary numbers that then get included with or combined with these real numbers. But for now, it's any number that you've ever used in math class, any answer you've had, probably any number you can think up is going to be a real number. It includes rationals and real. So it includes rational and irrational numbers. So numbers that can be written as a fraction, numbers that can't be written as a fraction, decimals that stop, decimals that repeat, decimals that go on for forever, no decimals, fractions. All those are in real numbers. So any number you've thought of so far. We okay to move on? Yeah. All right, then the last part for today, just want to look a little bit more at those square roots. So Roman numeral 2, positive and negative roots. And I want to kind of label something that we started using in the last section, is that when we have this sign here, often it's referred to as like the square root sign, but it also can be used for cubed roots and fourth roots and fifth roots. But the name of that is going to be a radical sign. So radical sign. If you have one of those radical signs, it always is going to give you a positive answer. So I'm going to say dash gives the positive, sometimes they refer to it as the principal, gives the positive square root. And kind of, I'll do an example to kind of explain, to demonstrate kind of where that's coming from. That if we were to do square root of 16, square root of 16 equals, anyone? 4. And we were talking in the last section that it equals 4 because 4 squared, which is the same as 4 times 4, equals 16. That radical is saying what number times itself, what number squared gives you that number inside the radical. Agreed? 4 times 4 is 16. What other number times itself equals 16? And you just need to think outside the box. You're trying to think of numbers other than 4, but if you look up here, it gives the positive square root. What other number times itself gives you 16? Okay, I just didn't hear you. Did you say it? Okay, so it's negative 4. So that you could say negative 4 squared. And some books make you put parentheses around it. Your calculator, if you do negative 4 squared, likely gives you an answer of negative 16 because it's working right to left. It's doing the 4 squared and then applying the negative. If you put it in parentheses, it'll work for sure. But that there also equals 16. So the radical symbol then is just going to give you that positive answer every time. Okay, so if a positive number, so if I'm here and I have a positive number squared gives me a positive, if I have a negative number squared gives me a positive, then what has to be true about any number inside the radical? It has to be positive, because you're saying what squared gives me that number? Well, if squaring a number gives you a positive, so I just want to write then, maybe I'll put it in purple for dramatic emphasis. I'm going to say square root. You have to have a positive number only. So make the line longer. Make sure your radical goes all the way in. But you have a positive number there only because basically if you're doing a positive squared, it's going to give you a positive. Or if you have a negative number squared, you get a positive. So if a radical is saying what squared gives me that number, you have to have a positive number in there because there's no other option. Now, it is possible to get a negative solution. And when they do that, what they'll do is they'll write it this way. So I'm going to switch back to red. If they want the negative answer, they'll actually put a little negative sign in front of the radical. Then that will give the negative square root. Because this part here, the radical is going to give me a positive. So then if I put a negative in front of it, it'll be a negative of a positive, giving me the negative answer. So going back to the example we did before, if I had negative square root of 16, that now is going to give me that negative square root. It's going to give me a negative 4. Because this here is positive, and then when you have a negative of a positive, you have a negative times a positive, it's going to give you that negative answer. We okay up to there? The very last thing that you're going to see pop up is once in a while then they'll do this symbol, plus and minus of a square root of 81. So they're saying it's the positive square root of 81 and the negative square root of 81. Square root of 81 is 9. So your answer then would have to be plus or minus 9. Because you could get the positive square root or you could get the negative square root. So positive or negative 9.